for the intro. I'm really excited today to tell you about the cutting-edge issues of trustworthiness and energy efficiency in AI systems. And in particular, I want to present an approach that we are taking at NTT Research, which is to use these empirical and theoretical tools from physics, which is a way we've been understanding complex systems in nature, and apply it to study artificial neural networks. So first, I want to make a point that, as you've been noticing or not noticing, AI is now everywhere. And there is almost like no day where none of us are going to interact with AI. I'm going to show you quick examples. The first one is smartphone. When you're opening smartphone, visiting any website, and you get recommendation, in the behind, there's an AI. When you're voice typing, again, there's an AI. And maybe you've already seen in the city of San Francisco that there are cars which is driving without any driver. And on these cars, again, what's sitting at the driving seat is AI. It's like it's really replacing the way we've been driving the car with our brain by artificial intelligence. And these AI systems are increasingly applied in safety critical scenario, in particular medical diagnosis, where judgment of an AI given some, let's say, medical image, and then giving diagnosis, this decision that AI makes can impact any one of our lives in a significant way. And finally, what we've seen over the last 1 or 2 years is a revolution of generative AI, where now we can interact with the AI, in particular, converse with the AI with natural language to generate content. And this is one of the latest examples from OpenAI Sora, which is we give some textual description of, please give us some video, movie, which is with sea animals driving on a bicycle and running on the ocean, and then it generates a really remarkable movie like this. And it's really a non-trivial thing that AI can do, because to generate such an image, the AI needs to learn the basic concepts of what dolphin is or what penguin is, etc. And it also has to understand what it means to ride on a bicycle. And again, I don't think AI has seen a movie where animal is riding on a bicycle much, at least not much. Okay? And then you have to combine all these basic concepts that the AI has extracted from the data in a non-trivial way, in a new way, to generate such image, right? So the ability of generative AI is really getting, in particular domain, to the ability that we have, our human have, in a significant way. But next, I also want to show you some example where AI is, the way AI works is different from how our intelligence works. So in a way, AI is like an alien intelligence that we don't fully understand how it works. So here's an example from, again, the latest model of OpenAI. If we ask it to generate image of 4 people, it outputs this really beautiful image of people with diverse ethnicity and beautiful clothes, everything on the background landscape. But then if you count numbers of how many people you've seen in the image, it's like 1, 2, 3, 4, 5, right? So it's kind of crazy how fine detail that AI can draw, but then it misses this really basic concepts of counting numbers wrong. Another example of misunderstanding of basic concept is this one, where the prompt was draw a blue triangle in between 2 red squares. Again, it doesn't really understand what it means to be in between. These are such an intuitive concept for human like us, but then it's non-trivial concept for AI. Here is another intuitive optics example where we ask it to generate an image of a panda through the lens of a magnifying glass, right? Again, it's a really cute image where there's a panda's face, cropped almost, inside of a magnifying glass. But then, again, it's missing the basic intuitive optics, like where does a panda's body go, right? Finally, we can also test it for intuitive physics, intuitive mechanics, where the prompt was a small light bulb and a large heavy ball balanced on a seesaw. Again, if you look at the surface, it looks fine, but then when you look at a step further, the light bulb is placed equally distant from the center with the heavy ball. And then even this really beautiful curvy seesaw, it's mechanically unstable, right? So the whole point of AI's training objective has been to generate something, either it's a language or image or video, that looks beautiful at the surface to us. But then there is a question of how deep understanding that AI has developed under this particular objective. And this really motivates us to study, really do a careful study of intelligence, because these alienness has real-world impact again, in particular in the field of trustworthiness, right? So there has been already real cases where AI system deployed in, let's say, in this case, making a decision about the credit card limit, picked up some sexual bias, which was a huge issue for this credit card that a company has shipped. Or AI also talks like they know what they're talking about, but then misses like facts in detail. Again, that had some real consequence to Google. Or another intense debate right now is that whether images that AI generated, whether they are violating the rights of the artist, because all the image that goes into the data sets are often drawn by real people, either using computers or not, right? And then the question is, okay, are these novel new images that AI is generating, like, is it really new? What does it mean to even like really new, right? It's not exactly the same. AI changes something, but then is it a fundamentally new image or not? Like, how do we define it? And then these are not just philosophical debate. We have to enforce something in law if we take it seriously, right? And finally, AI system, as I talked already, is now combined with cars or robots and everything. And even military use cases are rising. And some people, in particular, this leading researcher like Jeffrey Hinton, he really worries about AI might overtake like human race in many ways. And then some people are seriously discussing these like existential risk, right? And all of these, what we have to do to solve any of the problem is to first better understand the system. Because unlike traditional computers, AI is a complex system of itself. What I mean by that is that in a previous paradigm, when we interact with a computer simply runs an algorithm based on the program that we write, right? And the whole point of computer is to execute the well-defined algorithm without any error. And it's really rare that we run an algorithm and get a surprise out of it. Whenever we see some surprise out of computer, it's mostly the bugs, the mistake that you made in your program, right? But then the situation is different for AI. So what's really inside of AI is like over 100 billion parameters. So these are adjustable parameters. And then these 100 billion parameters are optimized on trillions of words. In particular, the task-4 language model, for example, is to predict the next word given part of the sentence, right? And by doing this iterative update of these 100 billion parameters, AI gets smarter and smarter. And one example of this nature is that most of the ability that these, let's say, ChatGPT has, which is, for example, doing some basic arithmetic calculation or translating phonic alphabet or even solving some math word problems, these capabilities emerge. What I mean by that is that the x-axis on the plot is the size of the neural network. It's how much compute that you need, which is proportional to the size of the neural network, amount of training that you do, or even the size of the data, right? And what you see is that no one could really predict what happens. But as people have been keep scaling up the system, making the AI bigger and bigger, there was some transition point where AI, which was not, let's say, which could not solve the math word problem, suddenly have become capable of solving math word problem. And then again, these are unpredictable. Even the creator of the AI don't know what the algorithm that's running behind or when that capability emerges, right? And this situation, in a way, really resembles what we see in physics. So this is an example of superconductivity. This is a phenomena where we see when a lot of electrons are interacting together. And on the plot, if you keep lowering the temperature of this particular metal, there is some particular transition point where the electric resistivity suddenly drops to 0. So people have been excited about it as an efficient way to transport electricity, for example, right? And the way we have been dealing with these situations, which I call engineering with emergent phenomena, which is a common in physics, has been to first understand how this phenomena of superconductivity emerges out of these interacting many-body particles, which is kind of resembles a situation in neural network where we have interacting neurons doing computation together in a non-trivial way. But then, by repeating some experiment and theoretical model building, we have better understanding. And once you understand it better, then we can turn it to engineering principles, because we know what's going to happen in a system if we change the parameter of the system, right? And because of this reason, I want to make a case that intelligence might be the new frontier of physics. And there is a historical trend about it, which is that with the first industrial revolution, where the steam engine has drove the industrial revolution, the thermodynamics has emerged. If you look at the timeline, around 1712, the first commercially successful steam engine was shipped. Okay? And then it took another half century for the Watt steam engine, which was a key driver for the first industrial revolution, got really popular, which resembles the way neural network has been evolving. It took 50 years for the technology to basically shoot up and then become widely adopted in society. And then what's remarkable is that it again took yet another half century for us to better understand how steam engines work. In particular, this military engineer, Sadi Carnot, asked the principal question about, okay, what is the limit of efficiency? And can we, for example, run the steam engine forever with fixed amount of energy that we now already know that's false, but then we now better understand it. And then after it, every time new technology comes out, like engines or transistor or liquid crystals, or right now, AI, there has been accompanying field of science that has emerged together. And then I believe that's going to happen in both science of natural and artificial intelligence. Let me give you a flavor of what we do in the real research. So I've already shown you some failure case of image generation model, but we have focused on the particular example where AI models fail to compose shape and color, in particular species of an animal and color. In this case, you first see lizard with different color. These are all right. Next is a fish with different color. These are all right. But then if we ask AI models to generate panda with different colors, somehow it cannot really compose a panda and different colors, right? So the question is, why is it happening? This is such a complex system, we cannot really start serializing or experimenting with this scale. So the first step that physicists often take is to reduce the complexity of the system to make it as simple as possible, but not simpler, as Einstein said. So here's a system that we have built with our own hands, right? So the task for the AI, what it has to learn is that first we give a combination of text and image. In this case, one of the elements of the text should correspond to the color, another one should be shape, but then we haven't really told the machine how they relate each other. But then we're going to ask the question of, okay, what is 2B, right? So this is what the generative AI is doing when it's learning from vast amount of data. Please make a guess. The answer is blue triangle. The way we human get to it is that first you have this red circle, and then you have another example where one of the attributes in this color shape is different. And then you associate 1 to be circle, 2 to be triangle. And then next we see blue circle, and then get that, okay, A and B corresponds to different colors, right? And then what's really exciting for science is that now we can seriously think about, can we build a mathematical theory of imagination? If I hear this question like 5 years ago, I was like, okay, are you really serious? How are we going to even test the theory, right? Because the only way so far to test the theory of intelligence has been just with experimenting with human, which is not that easy. But now we have AI system, which is complex, but then we can get all the numbers out of it. We can build a theory, make a mathematical prediction, and then test them, sharply conclude whether the theory is right or wrong. Let me give you one example. In this case, we have decided to represent all these combination of shape, size, color on a graph, right? And then in the training set, we include all the geometric objects without question mark. And then the test for the machine is asking whether the machine can generate these question marked geometric objects, right? And in particular, on the graph, what it teaches us is that there is some particular distance. So 3 of the question marked objects are 1 distance away from any object that we show in the training set. And then this diagonal little blue triangle is 2 distance away, right? So now we can build a hypothesis saying maybe when machine learns something, machine goes some particular progression of memorizing what it has already seen, step 1, step 2. And then that's what we see in the learning dynamics of the machine, right? So this is one example of theory and experiment combined together to better understand how the learning of concepts, combining concepts works. And we can also turn it into practical application. So this is not just scientific interest, because this fairness issue is really critical in AI. And then what we have shown is that the additional investment should be made to make the AI more fair. And we, instead of using different shape, etc., we can turn it into human face attributes, and then we've shown this statement to be correct. Let me then move on to what should we see in the far future, right? So the trend that we have been seeing is that when the computer was first built, people are writing assembly language, which is almost like a bare-born language to communicate with a computer that only experts, real experts, can write and communicate with a computer. After it, we have Fortran, C, Python, like more and more intuitive programming language that almost like anyone can learn to code if you want and talk to computer. But then this generative AI revolution has allowed us to interact with computer with natural language. We can speak it in English, Japanese, the plain natural language that we use in daily lives. But then if we really look ahead, finally what should happen is that the era where we connect this AI and our brain directly, right? And we are preparing for it at NTT Research. We are now doing a collaboration with Stanford University, who has a capability to record from the largest number of neurons. In this case, you see 10,000 neurons optically recorded its activity. So these like blinking stars like thing are neurons in the movie. And then the software side that we are contributing to is a technology to develop this like a digital twin under a minute. So the long-term goal is to record from the brain, understand what the state is, and then copy the state with a digital twin, and then compute the intervention. How should we control the brain? And then shine light to the brain to control the brain. And you can close the feedback loop, right? And then our method that we just published at NeurIPS last year has achieved the fastest and the most accurate way to create this digital twin. So let me conclude. So there's no doubt that AI is transforming society, but the whole point and the mission of NTT Research and this conference has been to upgrade reality, right? So it's going to change anyway, but then we want to make sure that the direction is going up rather than random, arbitrarily bad world, dystopian society, right? And for that purpose, we're going to try to integrate the all layer of society. First of all, we really do academic research, and then we're trying to bridge different fields like physics, brain science, and computer science together to identify universal mechanism that we can explain how any of these like animals or AI system think and behave. After it, NTT, it's a company, we can collaborate among companies and then deploy the understanding, this trustworthiness or energy efficiency. These are the real corporate issue that we can give a feedback to its business and deployment. And finally, as a rather like a neutral company, we can also talk to government and try to think about how we should regulate the system. And understanding is a founding pillar of this AI governance. And I love to work with any one of you, and then please reach out to us if you have any comment, thoughts, or opportunity for collaboration. Thank you very much.